If you want to do a hypothesis test using a critical value method, first determine what kind of hypothesis test you're doing. In this case, I have a hypothesis test for proportion with successes and n. To do this, I will go to Staplet, and I'll first do a categorical variable in a single group. And this will help me find the test statistic z. I can just do success and failure. And then I need to use 67 successes and then n minus x, or 268 minus 67 to get the failures. That's 201. Now I can see the relationship between these, as well as the sample proportion or success rate p hat, 25%. This claim was that HA, the proportion, is not equal to 34%. So we can see that 25% is significantly below that. We'll figure out how far below doing a one sample z-test and a not equal to match the alternative. Hypothesized percent was 34, or that might be entered as a decimal proportion, in which case it would be 0.34. So make sure you read that carefully. I have a very small z. Sometimes you get a p-value that's less than 0.001. I talked about that in another video. But when we're doing the critical value method, we don't even need the p-value. This problem only asks for the critical value and the test statistic. So I've got my test statistic for 3 decimal places. I'd want to round that to negative 3.110. So you can imagine a bell curve where we're 3 standard deviations to the left. We want to know if we're in the rejection region or in the critical region, same thing. To figure that out, we need a critical value. This part's a little different from previous problems. We'll go to Staplet normal distributions. And when we wanted to find a p-value, we calculated an area, but now we're doing it backwards. We're using that area alpha, which is the rejection region size, and we're figuring out what z would be at the boundary or edge of that. If it was a left tail test, we would do a left tail area of 0.005. And we need to just do a mean of 0 and standard deviation of 1 for a z curve. So we could do a left tail test or a right tail test with the alpha. For a two-tail test, we have to be a little bit more creative. This is a two-tail test because it's a not equal sign. So we've got to split that alpha of 0.05 into the two sides, divide it by 2 to get 0.025 for this problem. So I could get a left tail z of critical value of negative 1.960 and a right tail of positive 1.960. My test statistic was actually on the left, so that will be the one that matters more. We'll see that our test statistic is at negative 3, a little past it, so our test statistic is way down here in that critical rejection region, and that's what makes this method different. We use a visual comparison as opposed to just seeing if the p-value is smaller than alpha or not. If we're in the rejection region, we're far away from the null, which is in the middle. We're way over here with significant evidence to support that claim.